In this brief lecture, we look at equations of circles. We digress a moment from our study of polynomials to consider another important quadratic equation which appears often in calculus. This is an equation in which both x and y are squared, the equation for a circle. Suppose we have a circle centered at the point AB with radius r. Let x, comma y be any point on the circle. If you look at the figure taken off of the internet, we can draw a right triangle with short sides of lengths x minus a and y minus b and a hypotenuse of length r to represent any point of the form x comma y that's on the circle. This picture with the right triangle embedded in it of sides x minus a, y minus b, and hypotenuse r tells us that by the Pythagorean theorem, the quantity x minus a squared plus the quantity y minus b squared is r squared. This is the general equation for a circle with center AB and radius r. If we're given a quadratic equation in which x squared and y squared both occur together with coefficient 1, then we can recover the equation for a circle by completing the square. For example, suppose we're given the equation x squared plus 4x plus y squared plus 2y is 6. We can complete the square on x squared plus 4x, rewriting that as the quantity x plus 2 squared minus 4. And we can complete the square on y squared plus 2y, recognizing that y squared plus 2y is the beginning of y plus 1 squared, and so it's equal to y plus 1 all squared minus 1. And so our equation becomes, replacing x squared plus 4x by x plus 2 squared minus 4, and y squared plus 2y by y plus 1 squared minus 1, we get x plus 2 squared minus 4 plus y plus 1 all squared minus 1 is 6, or, moving constant to the right side, the quantity x plus 2 squared plus the quantity y plus 1 squared is 11. If we go back to our standard equation for the circle, we'll notice that this is an equation for a circle with center minus 2, comma, minus 1, and radius the square root of 11. We have used the concept of completing the square to find the standard form for a quadratic polynomial, to identify the transformation that turn the general parabola y equals x squared into any other parabola, to create the quadratic formula, and to briefly analyze the equation of a circle. In the next presentation, we will explore polynomials in general.